you for the invitation and also the introduction and also for the invitation to come here and to present what I'm doing. I'll give you a short introduction and some insights into what I think space can do for society and also on our way to tackle the challenges on Earth where we can use space technology. Actually, of course, the mountains. This is a satellite images that was taken last Friday from Sentinel 2 and is showing, maybe some of you already have seen, there is the Great Aletsch, but in my introductory, I will focus on this guy here. Some of you might know him as well. It's Rhone Glacier. Why Rhone Glacier? Actually, this is a picture I took in 2013 when I went to the fieldwork for my PhD in glaciology. So we had some fieldwork in the summer there, and what you see maybe already on the right is like this huge animal. It's the Glacier Cave, where you can in as a tourist, so it's very well accessible for everyone to go there, discover the glaciers. We went a bit further up, and when you hike down this path that you see just at the bottom, you pass all these images of the glacier has been there in 19 blah blah, and then it was there, the tongue, in 19 blah blah. But what's actually shocking me was then this one. This is from the same location, a picture of the glacial lake. So the lake that formed in front of the tongue. And it was actually not the first time I was on this glacier, but I was there around 7 years before for an ice course, for learning how to mountaineer. And at that time, we were actually just walking where the glacier lake is now, to the other side of this lake. And I returned 7 years later and was like, oh. Usually it's my grandparents saying, when I was young, that was like this and this, and now I came back 7 years later, and there was a huge lake where I did my glacier course. So I realized we see the changes, and it's changing drastically. What you can see here, I bring it back a bit further, so almost when I was born, which is a Landsat false color image of this same glacier. And I ask you to look at this, at the flash, where it's the glacier tongue, and now you can see like the lake is forming slowly until we come into 2020 as the last one. You also see the scale, so it's about 550 meters of retreat that is easily visible from space. What you can also see, there is not just the glacier evolving, but also the technology. So at the beginning, we had the NASA Landsat images from the 80s, and now we see at the end the higher resolved, higher quality data from the Sentinel. And I'll tell you a bit more on the Sentinel satellites in a second. Actually, 3 weeks ago, I was at the European Space Agency's Living Planet Symposium, which is a great conference about what satellite data can do, what new technologies arise, which satellites being built. And I realized, in fact, we shouldn't look at glacial retreat or like decreasing things on Earth, but we should look at the living planet. So we should turn it around in order to change. And that's also why I will not continue talking glacial retreat, but in 2 examples, how we can help with space technology to tackle the challenges. What you can see here is actually the already existing and current fleet of the European Space Agency satellites, and you see there is a lot of stuff around. What can you do with that? I'll focus here on this more or less already launched 6 types of satellites, the so-called Copernicus Sentinel family. So there are 6 different sensors up there in space, looking at the Earth. And now you might ask, but what did change? I mean, I showed you before images from the 80s, so the satellites were up there already then. We were able to look at the Earth as before. What is new now is we have these sensors up there. All the data is free and open available, in particular also for commercial use. There is a huge data volume, so there is tons of different data, different type that can be used to discover the Earth, to monitor the Earth. It's coming continuously. That means the satellites are circling around, taking the picture from the Earth all the time, and then it's delivered in a high quality and reliable way to the customers, so to us. Every one of us can access this data very easily. And in particular, as you can also see in the middle of the two boxes, it's a long-term perspective. So the first 6 types of satellites that have been launched, second generation is already in planning, and there will be another 6 other sensors which have the same goal. So there is a plan of around 40 or more years to have always the same highly reliable data. I'll focus on Sentinel-2, which is actually the data where the data comes from when I showed the time lapse at the beginning. So for Sentinel-2, we have actually 22,000 images needed to once picture or image the entire globe. But Sentinel-2 is imaging the entire globe every 5 days, once. That results in 1 million images per year. That's a huge number. And actually the issue we have now, we have a huge amount of data, not to forget the other Sentinels, not just the Sentinel-2, but how do we get the information out of it? And that's actually the challenge that we face now to really get useful information out of the data. And I show you some examples where I think this has been very well done from startups and companies. So my first example is from Exolab, a Swiss startup who created the portal ExoSilva and is active in forest health and monitoring of forest. What you can see is actually this area in Saint-Ursanne in Switzerland. Some of you might know it. And what you can see on the slide below, on the picture, there is a time series of an adapted index that tells you how is the forest. Is it declining or is it getting better? So if it's blue, it's getting better in the health, and if it's red, it's getting worse. And what you can see, it's like more or less 2018, there was a drought, but in 2021, there was a huge drop, and it was actually a strong summer storm that kind of destroyed the entire forest. So you can really well see, okay, there is an issue with this forest. And what you can do now is, for instance, if you replant, do reforestation, you can monitor again, did I do a good job in planting new trees or new vegetation? And in addition, what you can also do, what I think is a very nice example, is to have an alert in case of how is your forest evolving. So you can have on like 10-meter pixel size, it tells you, oh, pay attention, your vegetation, your forest has an issue, or you did a good job in reforestation, whatever, it's a healthy forest. The second example is coming from a complete other direction. You might remember this volcano outburst in Tonga in January this year. So you can see what happened with the small island on the inlet. So the entire island got blown up. This is again a Sentinel-2 image, by the way, because in the news there was another image. But even from Sentinel-2, that's very well visible. And this was actually then a reason to launch the so-called International Charter Space and Major Disaster Call. So they asked for help. Please, satellite community, map what happened in the surroundings, in the surrounding islands. And that's the product I show here on the right. What they did is just mapping where is the highest damage, where was the flood area, so where do we have to bring the rescue people. And this is also an initiative that is already quite old, but even in collaboration with commercial satellite providers, and not just open and free data. This is very focused on natural hazard, so you can not only monitor like damage, but you can also monitor where are floods, where are places that are damaged due to earthquakes, and so on and so forth. Then the third example I present here is from AgriCircle, which is a project called Sonnenskyer, which is on the third topic relevant for agriculture, so optimized agriculture. How can we grow crop very sustainable and as efficient as possible? What they did, they combined satellite data with in situ, so on ground measurements, together with drone measurements, and they mapped the soil. the soil quality, and then I can give recommendations on what type of crop should or can be grown, what is about the water availability, how is the quality. And this is often used in general in agriculture to have a better use of fertilizer or water, or having the best plants for this area of interest in order to optimize the crop and the yield. If you're now interested in the examples I showed you, I can tell that there are many different portals available. Maybe it sounds still a bit abstract, but actually it's very easy to get to the data. You can just, for instance, go to the EO browser, the tool I used to create this time lapse, and have a look. So when was the last image taken? Actually, I show you here the last image from the 15th of May, which was the last one, cloud-free. I just realized, actually, here at EPL FL, there are quite often clouds. And I can promise you already, when you check, there is a new image from yesterday, but there is, again, exactly on the campus, a small little cloud, even though it was good weather yesterday. You can explore it very easily, and then even find your house or wherever you want. Exactly. With that, I thank you for your attention, and I'm happy and open for any question.
Thank you so much. So we have microphones. If someone would like to ask a question, you're welcome to do that. Otherwise, Slido is open again. So if you just look up slide.do code showcase, I'd love to get any questions for Claudia. Can you tell us a little bit about, I guess, what you're working on for the rest of, let's say, this quarter? Because the big thing that I was thinking about when I was listening to your presentation is so much data. There's so much you could be doing, so many different ways you could be using it. What are you personally using it for at this moment?
I'm working, when I'm doing some research, I'm using it for biodiversity assessment. Mm-hmm. So I'm looking at the yearly cycle of the vegetation. When does it start to flower or to have leaf created, and then when it's summer season and when it starts for them again to go towards the winter. So you can say something about how is the vegetation season changing, what are the effects of droughts. That is a big topic now in the community because we have more and more droughts, and how is the vegetation adapting on all these challenges.
Thank you for answering that. I think we have a question over here.
What do you foresee in terms of the development of space technology, and where would we be in 2032 if we use this space technology, and how do you see it developing?
I think I see it if we see it from a user perspective, I would say it will be in our daily life. I see what happened actually with the GPS technology. I mean, some 20 years from now, I'm a surveyor from training, so we used GPS already from the very beginning, but no one was using it in their daily lives. And then there was the smartphone actually arriving, and then suddenly now everyone is using it every day, but no one really realizes what technology is behind. And I think that's exactly what will happen I don't think it will take that much longer. There will be one point this revolution that it's just, it's already included, for instance, in Google Maps. If you look in Google Maps and you search where to go, you see at the very bottom where you see the data, where the data came from, and usually it's either Copernicus data or whatever, Landsat, or even the private companies. So I think it will be just, no one will realize it and everyone will use it.
Do you have any idea what sort of applications, obviously GPS we use to get from one place to another, satellite data 10 years from now, besides getting from one place to another or looking at terrain or something of that sort, can you think of any applications for everyday use that we just pull out our phone and?
That's actually a good question. I think that's the challenge at the moment where most of the people face. For me personally, I'm a mountaineer, so I love skiing and ski touring. One thing that I'm using is okay, if I plan a tour, I just have a quick look to the last satellite data and I see, okay, yes, it's still snow covered, or it's not snow covered anymore, and I will go to another place. Yeah. It's Switzerland. So this would be one of my daily applications.
Nice. Can you detect high concentration of CO2 or emissions?
CO2 is a tricky one. actually. What is nowadays in the community done, we go rather to NO2 or methane detection. There is a new space mission in planning and development already that is really tackling CO2. But it's still a bit challenging, but we will get there soon, I guess.
Okay, and maybe one more question. You talked a lot about the use of government satellite data. What is the role of commercial satellites in data?
That's a very good question. I get asked that often. There are many constellations up there now. There are many data available. From my perspective, it's still tricky because on one side, they're still very expensive. They're high resolution, but there is always a bit of question on how, because with the high resolution satellites, often they're not available when you need them. So you have to task them, you have to order or ask. And so for me, it's still a bit tricky to bring them into a long-term stable business case, let's say, because with this one, you know exactly it's coming for the next, whatever, 10, 20 years. So if you develop your product, you know it will be sustainable because you can always use the same data. So from my perspective, I see the high-resolution and commercial satellite as an additional data set together with the open and free one that is a bit lower in resolution normally. But I think the use cases that are coming and the commercialization as well. So there is a lot of data out there also in the future. So I think we can do a lot with that.